All right, geometry. Today we are going to take a look at 10.4, which is the area of regular polygons. And I would say from the outset, of all the things we are going to do in this chapter, this tends to be the one that is the most difficult. And I say the most difficult only because it's the one that you haven't seen before. This is the only real new one for you. And so we have the area of regular polygons, which can mean lots of different things, right? We could be talking about triangles and squares, so equilateral triangles and squares, right? A regular polygon, if you recall, just a quick side note, regular means all the sides and angles, are congruent. So we're talking about equilateral, we're talking about a square, but you have, pentagon, hexagon, heptagon, octagon, so on and so forth. So you have all these shapes, and each one's different, and yet they all have the same formula. All right, and one of the ways that we'll learn to do this is actually using composite figures. So really quick, just a reminder, a composite figure is a shape or a figure made up of other shapes. All right, and so as we're looking at these shapes, you're thinking of something like, you could have something crazy like a little rocket ship, right? Where it is made up of, like you guys did your tangrams, right, the other day. It's made up of other shapes. Sorry, that's not very symmetric. So you have something like that, and you had to find the area of each shape and kind of add them together and maybe like not include this area because that's glass or something, right? So we're looking at things like this, and this is going to help us in order to find the area of polygons at some point. So a couple of vocab words for us that we're going to deal with. All right. When we're dealing with polygons, there's a bunch of different concepts to deal with. So you need to know or be aware of polygons have central angles. Okay, and this angle right here would be a central angle, and oftentimes to find that central angle, all you're going to do for regular polygons is 360 divided by the number of sides. Put a little arrow here, the number of sides. And that'll give you a degree. Again, this is only for regular polygons, but that's what we're dealing with most often. Okay, and then next it says a radius of a circle. Now that's kind of weird because when we think of radius, we think of radius of a polygon, we tend to think of circles, like I said, right? So what happens is oftentimes these are actually, see if I can get this to be somewhat of a nice circle here. And we'll make it a little bit bigger. All right. So oftentimes these are inscribed in a circle, and so the radius is any point from the center to one of the vertices of the shape. So notice even up above, to make my central angle, I needed 2 of these radii. So it's a segment, I'm going to write this down, segment from center to vertice or vertex. All right. And then we have this thing called an apothem, a little different. Okay, this is new, and for these shapes, for any, I almost said pentagon, this is a hexagon, for any polygon, the apothem goes from the vertex, so this is a segment, I'm sorry, I said vertex, I'm having a hard time with my words today. It goes from the center to the midpoint of a side. Okay. If I were to focus on the triangles, and I think we can kind of see this for a minute. If I look inside of the shape, I think you guys see that it's actually made up of a bunch of triangles. Okay, in this case, actually 6 bigger triangles. The apothem is, I could also say it's the height of one of those triangles. Okay. Or I could also call that, because it goes from a vertex to the midpoint, It's also the median of a triangle. All right, so you have all these different things, but you end up with, again, the apothem of a polygon. All right, and let me put my radius back up there. All right, and I don't know why I wrote this one twice, so my apologies. Central angle of a polygon I wrote twice. We'll just draw another one, right? So you have some vocab words that would be really helpful for us as we start talking about these and dealing with them. All right, so take a look at an example. Something as simple as this. It just says find the measure of the central angle and label a bunch of things. So I wants us to identify the radius, the center. Okay, that would be x. All right, it wants us to say what the radius is. I think we had that in blue. The radius would be either one of these. We'll just put this one, but xq or xr. The apothem is actually already in pink, so we don't need to really do that, but that would be an apothem. And then the central angle, which I said was in red, would be this angle right here. Okay, and it says to find the measure of the central angle. Well, I said earlier, you just take 360, and because these are regular, and again, I'm telling you this is regular, it doesn't say it up in the instructions, but we're going to deal with regular polygons in this when we're using the formula that we're going to learn. So you just do 360 divided by 5, and you get 72 degrees. It's that simple, okay? That angle is going to be important for us. We'll deal with that a little bit more later. All right. Another example here would just be, it's asking us to find the measure of central angle. Again, 360 divided by 6 equals 60. Okay. I think, just so we're clear, you have, let's do a square. And we'll say central angle. These are ones that come up so often, you guys, that it's actually worth it if you just know those numbers pretty well. That way you don't have to do the math every time. Notice I skipped 7. Seven-sided shape doesn't come up as often. Okay, but these would be the ones that we're going to deal with, I think, most of the time in our class. So I just think these are worth it instead of having to do this like 360 divided by 360 divided by 360 divided by. Would be really helpful. And I'll even go a step further. Central angle. Let's come over here. Half of those values, we're going to need this later. Might be helpful to know as well. Not that you guys can't figure those things out, but I think it's worth it to know them and be aware of them quicker, because it'll make some of the other problems we'll see later a little shorter, at least seem that way. All right, so there are basically 2 ways to find the area of a polygon, and one is just recognizing that all of these regular polygons are made up of, as you can see here, a bunch of triangles, and all these triangles are equal. So if you know how to find the area of a triangle, you can find the area of the hexagon in this case. So they actually are really nice on this one. They tell us pretty much everything we need to know. All right, the area of a triangle. Okay, we're going to focus on this triangle here. The area of this triangle is 1/2 base times height. All right, and there are a total of, we'll put this, 6 pieces here, right? There's 6 of those triangles. So all I have to do is 6 times 1/2. The base, which is 3, and the height, which is 1.7. Okay, and I just multiply that out. I would get 15.3. In this case, it's feet squared, right? And I've been telling you guys to leave these off when we type into Google Classroom. I don't want you to not remember or acknowledge that it is squared units. But that would be our answer. It's really straightforward and simple. But what this does is it actually leads us to our second formula. Because if I were to rearrange this, I just want us to make the connection and see that if I took, actually let's use orange here, if I took this number here and this number here, 6 threes, you have 1, 2, 3, 4, 5, 6. You have 6 threes. I'm actually finding the perimeter. Right? That's what that does. And so it leads us to another formula, which is 1/2 perimeter times the apothem. And you could kind of even see in here the way they wrote this. Now, the apothem was the height here, right? This was what we were defining as the apothem earlier. So you're doing 1/2 perimeter times apothem, and they wrote it as n, the number of sides, times the side length, which is just the perimeter. All right. So let's take a look at this one and find the area of this. Okay, using this formula. All right, and this one's going to look harder. It's not. Okay, I want to make sure it's not any harder. In a sense, the reason this one is harder is because what they didn't give us. They didn't give us the apothem. And that's what is going to make finding the area of a polygon a little bit trickier, is they don't give you the apothem or the radius or the length of the side for some reason. Okay, so here's what I would do. All right, if I'm looking at this, I've got 1/2 perimeter. We'll do the perimeter because that's really easy in this case. I'll just keep that orange because was doing that in orange earlier, times the apothem. And the perimeter is really easy, 5 plus 5 plus 5 plus 5 plus 5 plus 5. So we have 1/2 perimeter, 5 times 6 is 30, times the apothem. And now I have to do some work. So we're going to take a side note. We need the apothem, and we need to figure that out. Now, I want to show you here now an example, shortcut version of how to find the apothem only for hexagons. So for hexagons, okay, the radius is equal to the side lengths. Okay, for this shape, all the triangles that are made here are equilateral. Okay, they're all equilateral, which means, just really quick, that this angle is 60, and this one's 60, and this one's 60. So this is 5. So I have, if I kind of zoom into that, I want to find the apothem going down the middle here. So this is what I want to find. This is the apothem. I know that this piece is 5, and then this bottom piece, I'm really zooming in on, let me highlight it in blue here, kind of half of that shape. And so that bottom piece is 2.5. And so this only works for hexagons, but it's kind of nice in the way this broke down is that I could do, I had all the information in order to do the Pythagorean theorem. A squared plus 2.5 squared equals 5 squared. Okay, a squared minus 6.25 equals 18.75, right? 25 minus 6.25, and the square root of that answer is going to be 4.33 ... Okay, so I'm going to write 4.33, but I want you guys to know on my calculator I've got that really long decimal. So when I do my math, I just keep that on my calculator when I do the last step. So when I multiply all this out, my answer is 64.95 ... right? So I would say don't round. If they do ask you to round, don't round until this step. So let's say they asked to round nearest hundredth. Now I would round, and this would be units squared because I didn't put in units. Okay, so what makes this a little trickier, a little longer, is very often you're missing a piece. You're missing something like the apothem. So like, here's another one. Okay, and this one's going to be slightly different. We're missing something. We have to think through, how do I figure that out? So first off, here's my formula: 1/2 perimeter times apothem. Okay, and again, you could find the area of the triangle and multiply it by 5 in this case. It's the same work, really. So I just kind of do this formula. If you'd rather just do the triangle and go from there, that's fine. So in this case, notice what's happening is I don't have much of anything. The 9 is not equal to this side here. Okay, I actually need to find the apothem, A, and I need to find this little piece. I'll call it X for now, and that's going to be part of my perimeter. Okay, in fact, let's kind of go around. There's 10 of these little X's. It's half of each side. There's 10 of them here. So I have to find X and then multiply it by 10 really to get the perimeter, okay? So the perimeter, I'll just make a note here, the perimeter is equal to 10, in this case, X. All right. If it was a hexagon, it would be 12X. If it was an octagon, it would be 16X because it's 2 for each side. All right. Now, again, notice, let's zoom in here. I've got the radius of this, which is 9. I've got the apothem, which I don't know, but it is a 90-degree angle there, and I've got this X. So if I have one side and I need 2 other sides in a right triangle, there is a way to do this. There is a way to do this. All I need to do is figure out how many degrees this angle is. And I can use sine, cosine, and tangent. All right, I don't know if you're dreading that, if it's been a while, right? So what we have to do is we have to figure out what this angle is. Now, luckily, we know that the central angle of this one, 360 divided by 5 is 72. And I cut that in half to get this little one, which was 36 degrees. And so what I can do to find both the apothem and X is sine, cosine, tangent. And the nice thing is, if you've set this up, the apothem is always the adjacent to that angle. That's not you're always going to find that top angle every time, right? This is going to work for every shape. And so the nice thing is, the apothem is always the adjacent, right? And so I have cosine of 36. Cosine, if you recall, sine of the angle equals the opposite over hypotenuse. Cosine of the angle equals the adjacent over the hypotenuse. That's the one we're using now. And tangent is equal to the opposite over the adjacent. So equals A over 9. And we would multiply both sides by 9 to get A. And likewise, sine of 36 equals X over 9. And we multiply both sides by 9. And so what I have, because this is kind of the way I do it, you don't have to do it. You can get the decimals of these. I just kind of like to do everything at one time. I just want you to see this. I have 1/2, and the perimeter is going to be 10 times this thing right here that we just found, which is X. 9 sine 36 times the apothem, which is this, which is 9 times cosine 36. So as long as my calculator is in the right mode, I can now just go to my calculator and I could type all this in. 9 sine 36 times 9 cosine 36. And I will get my answer for the total perimeter of this shape, which is 192.5889445 centimeters squared. And again, the reason I like typing everything on my calculator is I don't want to have to round until the final answer. And if I type in little steps, I'm going to have decimal, lots to keep track of. And so I just kind of write it all down and then let my calculator do the work at the very end, right? And that's okay. There's no reason not to use a calculator here, especially because we're doing sine, cosine, tangent. All right. Just so you guys know, tomorrow we have one extra day on the calendar for like just a work day going through problems like this. So on that day, I'll be available. There'll be a worksheet, and if you understand it, great. And if not, you can jump in on Zoom and work through it with me. We could go through some of the problems on that worksheet. Okay. So I want to make sure we really do understand this. It tends to be again, out of everything, it's the newest and most kind of intense, involved process. So look back to this example, and hopefully that'll help you out. All right. All right, last one. This is just a little different. I just want to make sure this is like basic simple shapes that we're dealing with. You're just adding them all together. So this is really good for your house project because that's what you're doing. But sometimes the shapes are like this, and you have to look at them and say like, okay, how do I find the area of all of these pieces? Well, always good to think through what you have. We actually have a circle, these two pieces together. So you have to find the area of the circle. Pi times the radius squared, and the radius of that circle happens to be 8 half of 16, pi 8 squared. There's one circle, the two halves put together. There's a rectangle, and the area of that is base times height, 32 times 16. And then there's a triangle, and you're going to do, sorry, let me erase this. I don't like that I put parentheses there. 1/2 base will go 32 again, and then height 15. And you're really just finding the area of all of those and adding them together to get a final answer. Okay, so when you see shapes that are like, wow, this is this weird blobby thing here, again, composite figures, we've talked about several occasions, are just finding all of these shapes and then adding them together to get a bigger picture of what's going on. All right, I don't think these are going to be as much of an issue. Again, I really want to make sure that we're focusing on this and asking questions on these ones if you have them. So again, don't panic. Today I want you to try, right? And then tomorrow and the next day will be practice, just to make sure that we're understanding these well. All right, look forward to talking to you guys more about these, and hope your homework goes well.